Okay. Why do banks pay you to provide their services? This is Module 3, Lesson 4. We're going to look at simple interest and compound interest. It says students compare the rate of change for simple and compound interest and recognize situations in which a quantity grows by a constant percent rate per unit interval. Now, this says simple interest is calculated once per year on the original amount borrowed or invested. The interest does not become part of the amount borrowed or owed the principal. So the compound interest, the difference here is that the interest is calculated once per period, but the current amount borrowed and invested, that interest gets added to the borrowed and the invested. Okay, that's the difference. So let's look at number 1. Kyra has been babysitting since 6th grade. She has saved $1,000 and wants to open an account at the bank so that she earns interest on her savings. Simple Bank pays simple interest at a rate of 10%. How much money will Kyra have after 1 year, after 2 years, after 3 years? No, just after 5 years. Okay, so 1, 2, and 5. Here we go. This is simple, except for the fact that this is a little bit of a dream because banks don't pay 10% interest. I don't know if they ever have, but they are nowhere close to that now. But here's how we find interest. It's called the rate of I equals PRT, where that is the interest equals the principal, which is the amount that you either have put in the bank or the amount that you owed, depending on if you are borrowing or if you're putting into a savings account. The rate is the interest rate. Here's the 10% here, and the amount of time, which for us is going to be 1 year, 2 year, and 5 years. Okay, so here we go. With the first one, we're going to have $1,000. That's the money that she put in at an interest rate of 10%, which is 0.1. And then for 1 year, so just 1, which means all we're looking for right here is what is 10% of 1,000? Well, that's going to be 100. So that it equals 100. But now what we have to do with that, we have to add that onto the principal to see how much is in the account now. How much will she have? Well, she'll have $1,100 because the interest was $100. What she put in was $1,000. Okay. Now let's do it for 2 years. So if she puts it in there, the $1,000 for 2 years, still at the same interest. Well, now let's do this. What is 2 times 1/10? That would be 2/10, right? And what's 2/10 of 1,000? Well, that's $200. But once again, we have to add that back to the principal, where we would get $1,200 at the end because we already put $1,000 in. The bank gave us $2,000, and so we now have $1,200. And now you know, of course, if it is same interest rate for 5 years, that's going to be 50%. So that's going to be $500. So they will make or have $1,500 after 5 years. Okay. Now, let's look at this little flow chart here. And that's what it says here. We have $1,000, right? That's how much we have now. That's what we're putting in, or Kyra has now. That's what she's putting into the bank. Well, 10% of the 1,000 at the end of the year is going to be $100 that the bank is going to pay the interest. So they're going to give you $100. And so 1,000 plus 100 is equal to $1,100 at the end of the year. So the same thing works for the second period. We have 2 times 10% of $1,000 $200 is the interest, and now they have $1,200. Okay, that is simple interest. Now Raul needs $200 to start a snow cone stand for his hot summer. He borrows the money from a bank that charges 4% simple interest per year. How much will he owe if he waits 1 year to pay it back, 2 years, 3 years, 4 years, 5 years? Okay, so we have the same thing. He needs $200 to start a snow cone, so that's how much he's actually borrowing. So he needs the $200. So he borrows $200. The bank's going to charge him at a rate of 0.04, which is 4%. And we have to do that for, I'm going to put Y, for however many years. Okay. So he's going to owe back the $200 plus whatever interest he accrues. Okay. So I'm going to come down here on our calculator, and I'm going to start with 1 because that's 0.04 times 200, and so that's $8 interest. Okay, which means at the end of 1 year, he's going to have to pay back $208. So he's got to pay back this principal as well. Okay, now if we do for 2 years, we're going to have 0.04 times 2, which equals 0.08, or 800ths, times 200, and that's going to be $16. So for 2 years, it's going to be $16, which means he's going to owe back $216. So if we do it for 3 years, we're going to have 3 times 0.04. 3 times 0.04, which is going to be 0.1200. So we got 1200ths times 200. And that's going to equal $24. Okay. Which means he will, after 3 years, he's going to owe back $224. Okay, so I think you can see how this works. 3, 4, 5 years, you're going to keep doing the same thing, plugging in 4 for Y and 5 for Y, and then you're going to have to add that back on top of your principal. Now, how would you do this so that you didn't have to add back your $200? How could we do it to where that's what B says, write a formula to know how much he will owe after T years. So how can we write a formula that we can just plug in any year and determine how much he owes? Well, let's call this A of T is equal to, T is going to be our time, so our years. Well, we've got our 200, right, that we've got to pay back because that's a principal. And then we have how much our interest is going to be. So we would just write that as our formula. Times T. Now, that gives us everything that we need because we're going to be automatically in this formula where we were having to go back and add the 200. This already includes the 200 in the formula. So there's no more going back and having to add it up. You just plug it into your calculator and you have it. So let's do that since we didn't do it for 5, let's do it for 5 years. Okay, I'm going to start on the right side. I'm going to go this way in my calculator. And I'm going to say 5 times 0.04 equals times 200. That's going to be my interest. And then I've got to add my 200. And that would be after 5 years, he would owe AT of 5 would be $240. Okay, so only after 5 years are you owing $40 back. Let's go to page 3. Okay, so here in 1600s, the banks realized that there was another way to compute interest and make even more money. With compound interest, banks calculate the interest for the first period, add it to the total, and then calculate the interest on the total for the next period, and so on. Show students the diagram below to help them understand. Okay, so what happens is the bank, instead of it just looking like you borrowed $1,000 and at the end of the year you get the interest for $100, it's basically like you're borrowing another $1,100 at the end of that year. So then they're going to get to charge you interest on $1,100 instead of just $1,000. And then so far on the next year. So here we have the 1,000. Well, 10% of 1,000 is $100. So after the first year, basically the bank gave you $1,000 and you owe the $100. And then they're going to charge you interest on that, which $1,100 plus your 10% of that $1,100 is equal to $1,210, which means after that, they're going to charge you interest on this full amount, not just the amount you borrowed, which is simple interest. Okay, we're going to continue, the bank's going to continue making you pay interest on the total amount, not just on the original amount that you borrowed. Okay, so you're basically paying interest on interest as well. And then you see this formula here. Okay, so this stands for future value. FV is future value. The present value. R is the rate. And N is the time there. Okay, this one takes into account what you started with. Okay, that's what that one is there. Okay, and so you're going to see this formula: future value